When a Linux service fails to start, crashes unexpectedly, or behaves in an unexpected way, you need a systematic method to diagnose the problem. On modern Linux distributions, services are managed by systemd, and their logs are collected by a component called the journal, accessed through the command journal. Mastering these tools is essential for both administrators and security professionals, because a misbehaving or compromised service often leaves traces in the logs that can reveal the root cause of an incident or an attack. Understanding the state of a service. The first step in debugging is always to check the current state of the service. The command systemtl status name.service gives a rich overview. For example, systemtl status nginx shows several key pieces of information. The loaded line indicates whether the unit file was found and whether the service is enabled, starts automatically at boot, or disabled. The active line shows the runtime state: active, running, inactive, dead, failed, or activating. The main PID line gives the process identifier of the main process. The last log lines associated with the service are displayed at the bottom, which is often your first clue. The possible active states are important to distinguish. Active, running, means the service is up and working. Active, exited, means a one-shot task ran successfully and finished, common for setup scripts. Inactive, dead, means the service is stopped. Failed means the service tried to run but returned an error. Activating or deactivating are transition states. When a service is in the failed state, systemd records the reason. You will often see a line such as active, failed, result, exit code, or result, signal, which tells you whether the process exited with a non-zero error code or was killed by a signal. Using journal to read logs. The journal is a centralized, structured logging system. Every message it stores carries metadata such as the timestamp, the unit that produced it, the process identifier, the priority level, and more. This structure makes filtering powerful. Basic and essential commands include: journal displays the entire journal, oldest first. Journal E jumps to the end, the most recent entries. Journal R shows entries in reverse order, newest first. Journal F follows the log in real time, similar to tailf, which is extremely useful while you restart a service and watch what happens. Journal unginx.service filters the output to show only messages from a specific unit. This is the single most important option for debugging one service. Journal USSHN50 shows only the last 50 lines for that unit. Filtering by time is also very useful. Journal since January 1, 2024 10 o'clock shows entries after a given moment. Journal since today limits output to the current day. Journal since 1 hour ago uses relative time. Journal until January 1, 2024 12 o'clock sets an upper time bound. You can combine since and until to focus on a precise window when an incident occurred. Filtering by priority helps you find serious problems quickly. The journal uses the same severity levels as the historical syslog standard, numbered from 0 to 7. 0 emergency. 1 alert. 2 critical. 3 error. 4 warning. 5 notice. 6 informational. 7 debug. The command journal.pr shows only messages at the error level and more severe, that is, priorities 0 through 3. This is a fast way to isolate failures without reading every informational line. You can also write journal.p3. Boot-related debugging. Problems that only appear after a reboot require looking at the logs of a specific boot. The option B targets the current boot, journal.b. To look at a previous boot, use journal.b-1 for the last boot, journal.b-2 for the one before, and so on. The command journal.list boots lists all recorded boots with their identifiers. This is critical when a service fails intermittently and you need to compare a successful boot with a failed one. Persistence of the journal. By default, some systems keep the journal only in memory. Volatile storage under /run/log/journal, meaning logs are lost at reboot. To keep logs across reboots, the journal must be stored on disk under /var/log/journal. This is controlled by the storage setting in the file /etc/systemd/journal.conference setting. Storage equals persistent, and creating the directory ensures historical logs survive. For security investigations, persistent logs are highly recommended because you often analyze events that happened before the last reboot. A typical debugging workflow. 1. Run systemtl status myservice to see the state and the last log lines. 2. If it failed, run journal.u myservice to read the recent detailed messages. Filter with pr to spot the actual error quickly. 4. Check the unit file with systemtl cat myservice to review the exec start command, the user it runs as, and its dependencies. 5. Try to restart with systemcl restart myservice and follow live with journal.u myservice f6. If the configuration file of the unit was modified, run systemctl daemon reload first so systemd rereads the unit definitions. Common causes of failure. A wrong path in the exec start directive, so the binary is not found. Insufficient permissions. For instance, the service user cannot read a configuration file or bind to a privileged port below 1024. A port already used by another process, producing an address already in use error. A syntax error in the application configuration file, which the service reports at startup. A missing dependency, such as a database service that is not yet ready. The process being killed by a signal, which appears as result, signal in the status. A concrete example. Suppose systemctl status web app shows failed. Result, exit code. Running journal.clu web app pre reveals the line permission denied, /etc/webapp/config.yml. The root cause is that the service user lacks read access to that file. Fixing the file permissions and running systemctl restart web app resolves the issue. Security relevance. From a cybersecurity point of view, journaled logs are a key source of evidence. Repeated authentication failures, unexpected service restarts, or processes killed by signals can indicate an attack or a misconfiguration. Because journal.ecl can filter by unit, priority, and time, an analyst can reconstruct a timeline of events precisely. Ensuring the journal is persistent and protected against tampering is part of good defensive practice. In summary, systemctl status tells you what state a service is in, and journal.ecl with its filters by unit, priority, time, and boot lets you read exactly the messages you need to identify and fix the problem.